Hi, this video will cover section 1.1 rectangular coordinates. The objectives for this section will be to plot points in the Cartesian plane or the XY plane. Second, to use the distance formula to find the distance between 2 points. And third, find the midpoint by using the midpoint formula. And here we're finding the distance. And then lastly, we will use a coordinate plane to model and solve real life problems. So this is a very easy section. I hope that we can make this video short so that you can get started with your homework on WebAssign. So Cartesian plane, we have it here. And you could see that we do have the x-axis, which is the horizontal axis. We have the y-axis, which is the vertical axis. You could see that. And we call this the rectangular coordinate system as well, or the Cartesian plane. And it is named after the French mathematician René Descartes, who lived during this time period. And it is defined, the Cartesian plane, to be two real number lines, one being the x-axis, that is a number line, goes positive and negative, intersecting at a right angle, as you can see here, with the other number line, so two number lines intersecting. Now, it's very important to notice that once those two lines intersect, we can see four different quadrants. And we are always gonna start by, it's important to label them. So the first quadrant is always where both the x is positive and also the y is positive. So positive x, positive y. Second quadrant, it's going to be where the x is negative and the y is positive. Then we have the third quadrant where the x is negative and also the y is negative. And finally, we have the fourth quadrant where the x will be positive, but the y will be negative. So we always start where both are positive, and then we go in this counterclockwise direction, meaning the opposite direction of the clock. So as we already saw in the drawing, the horizontal axis, or the horizontal real number line, is what we refer to as the x-axis. And of course, we have here vertical, that will be the y-axis. Also, I forgot to mention the point of intersection of the two axes is called the origin. And that's what you know as the point 0, 0 is the one that is located at the origin. So that point is right here, the origin. So in some problems, you may not be given the coordinates 0, 0, but the simple word origin that should tell you that 0, 0 will be used. And it's kind of convenient when you do have, let's say, a line going through that point. We will see why. So each point in the rectangular coordinate plane is called an order pair because we have two coordinates, as you could see here, with the origins 0, 0, 1 for x and 1 for y. So we will use parentheses. And when you're doing your homework on WebAssign, you have to be careful about using parentheses, about using a comma to separate them. And those two letters that we see here, x and y, they represent the coordinates of the point. And more specifically, this is the horizontal coordinate, and this is the vertical coordinate. The x-coordinate is going to represent the distance from the y-axis to any point. And so I would like to say more from the origin. And then the paragraph says from the y-axis, because even though we're looking for the x-coordinate, it's going to be the distance from that y-axis here horizontally to any point. And so that's that same distance that I'm talking about here. That will be x. And then the y-coordinate is going to represent the distance from the x-axis. So if we start at the origin again, here's the x-axis, and so the distance will be from there to here, and it will be considered y. So the same distance, it's there. And I like to refer to this more as just to remember that the x-coordinate represents the horizontal distance. And of course, this could be positive or negative, depending if you're going to the right, it's positive, and if you're going to the left, it's negative. Now, for the y-coordinate, I like to think of it as the vertical distance. By the way, these PowerPoint slides are on Blackboard, so you could download a copy or print a copy and then just write what I'm adding to them. If you have a printer, you could print them and then do that. If not, make sure, feel free to use the slides as you want. You are also expected to take notes and upload those on Blackboard, so don't forget that. Keep all your notes. You are supposed to be taking notes. Now, moving on, so x-coordinate, horizontal distance, y-coordinate, vertical distance. And so what we're going to do first, just to have a quick review on how to plot points in the Cartesian plane. So we're just going to see how those points will be graphed. And we have the first -1, 2. And so we'll have -1. We will always start from the origin. In fact, let's graph the origin, which is here, 0, 0. Remember, that is the origin. Now for -1, 2, we go -1 in the horizontal direction and then 2 in the vertical direction. And so that is going to be the point that we see here, -1, 2. And you could actually see the dash lines are telling you the distance, the horizontal distance, and the vertical distance from the origin. So moving on to the next point, 3, 4. It's going to be located at 3 for the x-axis, for the x-coordinate, and 4 for the y-coordinate. So the point is right here. Then we have 3, 0. So the value for the x-coordinate is +3, so it's here on the right side. And for the y-coordinate, we have a 0, so the point did not go up or down. It's still on the x-axis. And finally, the point -2, -3 it's going to be here. Negative for the x and negative for the y. So just to remind you about the quadrants, quadrant 1, quadrant 2, 3, and 4. And remember, they always go in the counterclockwise direction. So now what we're going to do is move on to the next objective, which is the distance formula. But before that, we're going to go over the Pythagorean theorem, which is defined as negative a squared plus b squared equals c squared. And so if you look at, this will be a, and if you were to form a square of that dimension a, remember squares have all the sides are equal. So if you were to do that, and also let's say make another one here, something like that. So if you were to calculate the area of each square, it will be the product of b times b. So here will be b squared, here we will have a squared. That would be the area. So the idea is that if you add those two areas, you will get the same area of the square that we have here. So that will be equal to c squared. We also refer to that as the hypotenuse. I'm not sure if I spelled it right. Might be missing an H. So this will be c times c, and we have here c squared. Also, it's very important to mention that this theorem can only be used with right triangles. So there is a 90-degree angle there. And we could say that if that relationship is true or equation, then we could start with for a right triangle, that would be true. And the converse of it, like if you reverse the two statements, if you have the same relationship being true, then it is because you must have a right triangle. So going from that equation, so a squared plus b squared equals c squared. So let's say we just want to find c, not c squared. So what we will do is take the square root on both sides, and of course the square root will cancel here with the square because they are inverse operations. And here we will have the square root of a squared plus b squared. Now, I just want to mention that if you are looking for a or looking for b, then you could still derive that. So, but there's going to be a slight difference. There will be a minus somewhere in between. So let's say we want to solve for a, and so we will have a squared is equal to c squared now the positive b squared, I will have to subtract b squared on both sides. I like to just think that I manipulate variables to my convenience, taking them across the equal sign. So if the operation here for b squared is addition, once I move it across the equal sign, it's going to be subtraction because it will change to its inverse operation. And so that is minus subtraction. So minus b squared. And lastly, if I want to solve for a, not a square, I will have to take the square root on both sides. And so that will give me c squared minus b squared. So, that will come in handy. Also, if you had to solve for b, that will equal to the square root of c squared minus a squared. So, just so you know. Now, we're going to go ahead and move on to the distance formula from there. So with Pythagorean theorem, you are typically given the measurements of a triangle, a right triangle. And you could be given the hypotenuse, or you can be given one of the sides. Okay, let's say that you could be given two of the sides, find the hypotenuse, or you could be given the hypotenuse and one side and they want you to find the other, right? So let's pretend that here we have this is equal to, well, I'll just draw the same triangle over here, maybe not to scale. Okay, so we have a triangle there. And in fact, I'm just going to do something else. Okay, so it did not work. Let's just draw our own. Okay, so not too good, but it's good for now. So let's pretend that it's a measurement of 3. This is 4. So then this is one of the famous Pythagorean triples. So I know the hypotenuse is going to be 5. So with the distance formula, the difference between Pythagorean theorem and distance formula is that with the Pythagorean theorem, you already have the dimensions, either two sides, and then the big question is like, find the value of c. So in that case, of course, we will have c is equal to the square root of a squared plus b squared. And you are just able to substitute those numbers, one for a and one for b, into the Pythagorean formula, the Pythagorean theorem formula. So with the distance formula, you do not have those numbers. In fact, what you have is a set of 2 points. So one point will be x sub 1. That little number is a subscript, and it's just a label. It doesn't have a numerical value. So our first point is x sub 1, y sub 1. So as you can see here, the point is here, x sub 1, y sub 1. So we have a second point, which is x sub 2, y sub 2. And that point is located here. Okay, so if we need to find the distance between those 2 points, that will be here, D. And we're using D for distance. With Pythagorean theorem, most of the time we use the letter C, but it is also referring to the hypotenuse, just like that. So what we will do to find the horizontal distance and the vertical distance is we're going to take the difference of the horizontal coordinates, right? And that's why we have a minus. So the difference will be x sub 2 minus x sub 1, and that will give us the horizontal distance. Now we have to subtract because we are trying to find the distance between those two x values. So if you want to find the difference between, let's say, 10 and 7, you will subtract 10 minus 7, and it will give you -3. You could also subtract 7 minus 10, and that will give you -3. But if we want to talk about distance, we want our numbers, our differences, to be positive because distance is positive. And so that is why we use the absolute value, so that it doesn't matter how you label your points, 7 minus 10 or 10 minus 7. We want to have a positive number. So the way to make this -3 positive is to use the absolute value for the difference. And so the absolute value of -3 is going to be +3. So that's an example of why we see the absolute value there. Now, to get the vertical distance, of course, we're going to subtract the y coordinates. And so that is going to give us the vertical distance, which is similar to having already that number there for vertical. And so we subtract the y values. Again, we're talking about distance. We're talking about length. So we want that to remain positive. So that's why we use the absolute value symbol here and here. So now let's go ahead and apply this. Just to change the algebra a little bit. So we're going to have d squared. Now, if we are squaring positive, the difference, I can also replace it with parentheses, because anytime you square a difference of two numbers, you will always get a positive. So for example, if the difference was like our previous example, -3 squared, that will be -3 times -3, and negative times a negative is positive, so we get +9. But also if we had 3 squared, that will be 3 times 3, so that will also be 9. And so that's why we could stop using the absolute value and just use parentheses to indicate we will be squaring that. So we take the difference of the x values of the horizontal distances and the difference of the y values, or the vertical distance, and we square that, of course. Now from here we take the square root on both sides. That square root will cancel that square for d. So now we have d is equal to the square root of x squared minus x sub 2 minus x sub 1 square. And remember, when you are working with this type of problems, you have to follow the order of operations. So before you square anything, you must take care of the parentheses. You have to do what's inside the parentheses. In this case, it will be subtract those two numbers. Now, whether you get a positive or a negative result, once you square them, which will be the next step, the exponents, you have to make sure that your answer is always positive. Remember, we're talking about distance. And if you square a negative number, you're still going to get a positive result. One of the common mistakes is that students will enter this on the calculator, which is not the same as this one. What that one is saying is -1 times 3 square. And so that will equal to -1 times 9, which will be -9. So don't enter things like this on the calculator. If you're squaring a number, the result must be positive. So first you do what's inside each set of parentheses. You subtract, and then you square the numbers. And then after that, you could go ahead and add them. Then after you do that, then you could take the square root. WebAssign is very picky with this type of answers, so sometimes they might ask for the exact answer, and sometimes the exact answer might just be left in radical form, such as the square root of 2. Sometimes if it is something like the square root of 8, you might have to simplify it for WebAssign to be happy with your exact answer. I'm going to remind you how to do something like that. So we could factor 8, such as one of the factors is a perfect square. That would be a 4. So this will be 4 times 2. Then from here, the square root of a product could be the product of 2 square roots. And so from here, we could take the square root of 4. That gives us an integer, is 2. And the square root of 2 will not be an exact number, so we just leave it inside. So that's another example of an exact answer. If you could use an approximation, then that means that you could use decimals. They will typically ask you to round to the nearest tenth or round to the nearest 100 or something like that. So now let's get to an example of finding the distance. So we have here distance formula. I strongly recommend that you write down the formula every time you use it. This is one of those formulas that you are going to be using for a while, and it kind of never goes away. It's very useful actually. So we have our 2 points here. We have -2, 1, and we have 3, 4. So what we're going to be doing is, let's go ahead and consider, well, they're actually telling us here what they are already. So that will be the 3 is x sub 2, and then the 4 is y sub 2. Then for the first point, we have -2, 1. So that's right here. So we're saying -2 is x sub 1. 1 and 1 is y sub 1. So we're going to go ahead and substitute our values. Into the distance formula. Remember, we're looking for the distance between the horizontal coordinates. So we have to subtract. That is part of the formula. So we start by substituting x sub 2 with a positive 3 minus x sub 1, which happens to be negative. So here you have to be careful and keep those negative numbers in parentheses. And you might think that you don't have to, but you know, that's up to you. If you do it, you might be less likely to make a mistake if you use parentheses when you're substituting a negative number. It's just good practice. The next one is y sub 2, so we have a 4 from here, and then minus y sub 1, which is a 1. So remember, the negatives that you see here are indicating that we're subtracting the coordinates. And the negative that you see here is part of the number that we substituted. So the next thing for me to do will be to take care of what's going on inside that parentheses, and so the negative in front of a negative number is going to cause that number to turn into positive. So we have that. And remember, by the order of operations, we do what's inside the parentheses first. So the first thing was for us to clear this double negative situation. Then we have 4 minus 1. I'm just going to rewrite it right now so we can go kind of like at the same pace with the horizontal and vertical one. So now we're going to add 3 plus 2. That would be 5. And the square. Then 4 minus 1 is a 3. And then we square it. So D will equal to 25 plus 9. So that means that because 5 squared is 25, 3 squared is 9. And if we add those two numbers, we will get 34. Now the square root of 34. If we think about the factors of 34, of course, we have 1 and 34. Let's say 2 and 17. And that's it. Those are the only combinations of factors. So then none of those are a perfect square. So this will actually be the exact answer. Now, if you need to round, let's say, to the nearest hundredth, for example, so that will be 2 digits after the decimal point. And so for us to do something like that, I'm going to enter it on my calculator actually. I get 5.83. And for example, and there are more numbers after that, 0, 9, and other and more digits. So for example, if the question says round to the nearest hundredth, the answer will be 5.83. If it says round to the nearest tenth, it will be 5.8. If it says round to the nearest 10,000, that will be this 9 here. And let me see what's after the 9. There's actually a 5. So then, you know, that means I want you to keep 4 decimals. So it might be like 5.8. This 5, the fifth decimal, is going to cause the 9 to go up to add 10. So it will be 3 and then 1, 0. Okay. So, but most of the time you will be required to enter the exact answer. Now let's move on to the midpoint formula. And I like to think of the midpoint formula as the average. Here we have the average of the x's. And here we have the average of the y's. Okay, and what do you do when you take the average of something? For example, your first 2 exams, you want to know the average. Let's say you got a 40 and you got a 90. So what would you do? Well, you add the 2 values and then you divide by 2 because you have 2 scores, right? So in this case, that will be something like 130 divided by 2. First, actually, fraction bars are considered grouping symbols, such as parentheses. And so that's why I added the 40 and the 90 first. So 130, then I divide by 2, and that will give me 65. Not too good of an average. So that's what we're going to be doing every time we need the midpoint of something. So graphically, that will be, we have here 2 points, as you could see. That's 1 point. That's another point. In the midpoint, it indicates that it's exactly halfway between those two. So now we're not looking for distance. That was just one number. We're looking for midpoint. So since it is a point, it makes sense that it has two coordinates. Remember, points are order pairs. They have an x and a y. So for those are always going to be a point. So again, we take the average of those numbers. So we're going to have, let's go ahead and call this x sub 1, x sub 2, just to keep it that way. It doesn't really matter. You could label it x sub 2, y sub 2, and as long as you don't mix and match your points. So if we substitute, that's the first thing for the midpoint, and we're going to have x sub 1 is -5 plus, now we're adding because we're taking an average, not the difference. We're taking the average, so we're adding, and then we will divide by 2, plus x sub 2, that's a 9, divided by 2. So I just substituted here the -5 and the +9, and then comma. Now let's get the average of the y value. So y sub 1 is -3 and y sub 2 is +3. Then we divide by 2 because that's what the formula says. So y sub 1 goes here, and then y sub 2 goes here. And remember, we are adding because we're getting the average. So the midpoint is going to be, remember, first we add the numbers on top. -5 plus 9 is 4 over 2. And then -3 plus 3 is 0 over 2. So our midpoint is going to be 4 divided by 2 is a 2. 0 divided by 2 is 0. I want you to remember that 0 divided by any number is always 0. Imagine if you have 0 pizzas and you invite, I don't know, 100 friends. How many slices of pizza do each friend get? It's 0, nothing. But if we have the other way, any number divided by 0, that is a no. And we refer to this as undefined. This will be very important and useful once we get to the first functions that we will study, which are the linear functions. Okay, so moving on from here, we got 2, 0, and you could see the point right here, midpoint, and is exactly halfway. Average of the x's, average of the y's. So our last problem here will be to find the length of a pass, and it will be a pass from in a football field from a football quarterback and a wide receiver. So here we're going to consider the horizontal distance and the vertical distance, and we have that the football quarterback throws a pass from the 28-yard line, and that will be here, and that will be actually the vertical distance, in case you don't know football. I don't know any, but I think I've done this problem enough. So, and also 40 yards from the sideline. So that's going to be the horizontal distance. Okay, so that point is gonna be 40, 28. And our other point is going to be the wide receiver catches the ball on the 5th yard line, so that will be the vertical distance again, and 20 yards from the sideline, so that will be the horizontal distance. Oh, the pink just looks the same. Okay, so this point will be horizontal distance is the 20, the distance from the sideline, and the vertical distance will be the 5th yard line. So those are our 2 points. Now we want to find how long is the pass. So the question how long, it indicates length. And for that we will be using the distance formula. So I'm going to write the formula here again. So we need the difference of the x values and the difference of the y values. This is not midpoint, and we cannot put x there, it needs to be y. Okay, so we're gonna go ahead and take this point as our x sub 1, x sub y sub 1, just so you know that you don't have to pick the first point to always be x sub 1, y sub 1. So this will be x sub 2, y sub 2. So we start substituting. We get x sub 2, that will be a 40, minus x sub 1, which is 20. We square it, then we have a plus. Y sub 2 is a 28, y sub 1 is a 5, and then we square it. So then the distance, first we need to subtract there, so we will have 40 minus 20 is 20, square. 28 minus 5 is 23, square. And then we have to square those numbers first. So 20 square is 400. And 23 square is equal to 529. Now I'm going to go ahead and add those two. So 400 and 529 is 929. And if we take the square root of that, we are going to get an approximation of 30.48. And that is if I round it to the nearest hundredth. The answer that I got on my calculator was 30.4795. So if I look at this number here, it's a 9, the third digit, so since it is bigger than 5, it will cause the 7 to go up to 8. So that's why we round that way. So this is the last problem for this section. Your homework is already uploaded and it is due pretty soon, like I think Tuesday or Wednesday. So make sure you take a look at it, you work on it, and use the tutoring services. They are there to help you. They have extended hours and there are always tutors there, and you could also earn some extra credit while you do that. So thank you for watching.